Home wiring might seem mysterious, but it's based on simple principles. This guide will demystify the basics of electrical circuits in your home. We'll explore how electricity works, the components that make up a circuit, and how these components work together. We'll learn about series and parallel circuits, two common configurations in home wiring. Finally, we'll emphasize the importance of safety when working with electricity. Understanding these basic concepts can empower you to handle minor electrical issues, make informed decisions about your home's electrical system, and most importantly, stay safe. We'll use clear language and simple diagrams to make this complex topic accessible to everyone. Whether you're a homeowner, a renter, or simply curious about how things work, this guide provides a solid foundation for understanding the electrical circuits that power your home. This journey into the world of electrical circuits begins with the fundamental concept of electricity itself. Join us as we illuminate the path of electrical current and unlock the secrets behind your home's electrical system. Let's break down the complexities of home wiring into easily digestible pieces. Together, we'll shed light on the fascinating world of electrical circuits. Electricity is the flow of electrons, tiny particles that carry an electric charge. This flow is much like water flowing through a pipe. Instead of water, we have electrons, and the pipe is replaced by a conductor, a material that allows electrons to flow easily. Conductors are often metals like copper, which is commonly used in household wiring. Voltage, measured in volts, is the force that pushes electrons through a conductor. Think of it as the pressure pushing water through a pipe. Current, measured in amperes or amps, is the amount of electricity flowing through the conductor, similar to the amount of water flowing through a pipe. The higher the voltage, the greater the force pushing the electrons and the higher the current. Resistance, measured in ohms, is the opposition to the flow of electrons. It's like the friction water experiences as it flows through a pipe. Materials like rubber have high resistance and are called insulators, as they resist the flow of electrons. Understanding these three basic concepts, voltage, current, and resistance, is fundamental to comprehending how electricity works in a circuit. An electrical circuit is a closed loop or pathway that allows electricity to flow. It's like a complete circle of pipe that allows water to circulate. A circuit consists of several components, each with a specific role to play in controlling and utilizing the flow of electricity. These components work together to ensure a safe and functional electrical system in your home. The power source, typically a power plant for home wiring, provides the voltage that drives the flow of electrons. It's like a pump that pushes water into the pipe. Wires, made of conductive materials like copper, act as the pathways for electrons to travel. They're like the pipes that carry water. Switches interrupt or allow the flow of electricity, much like a valve controls the flow of water. Loads are devices that consume electrical energy to perform a function, like a light bulb, a motor, or an appliance. They're like the faucets or sprinklers that utilize the water flowing through the pipe. Each of these components plays a crucial role in a functioning circuit. They work together to ensure that electricity flows efficiently and safely to power the devices in your home. Section 4. Series and parallel circuits. Different paths for power. There are two main types of electrical circuits: series and parallel. In a series circuit, components are connected one after the other, forming a single pathway for electrons to flow. Imagine a single pipe with multiple faucets connected in a line. If one component fails, the entire circuit is broken, similar to how closing one faucet in a series would stop water flow to all subsequent faucets. In a parallel circuit, components are connected on separate branches, offering multiple pathways for electrons to flow. This is like having multiple pipes branching out from a main pipe, each supplying water to a different faucet. If one component fails, the other branches continue to function, allowing water to flow to the remaining faucets. Most home wiring utilizes parallel circuits. This ensures that if one device fails, the other devices on the circuit remain operational. Understanding the difference between series and parallel circuits is crucial to comprehending how electricity is distributed in your home. It also helps in troubleshooting electrical issues and understanding the impact of adding or removing devices from a circuit. Section 5. The circuit in action: flow, switches, and loads. When a circuit is complete, electrons flow from the power source through the wires to the load. This flow of electrons powers the load, allowing it to perform its function. For example, in a circuit with a light bulb, the flow of electrons through the filament of the bulb causes it to heat up and emit light. Switches play a crucial role in controlling the flow of electricity in a circuit. When a switch is closed, it completes the circuit, allowing electrons to flow. When a switch is open, it breaks the circuit, stopping the flow of electrons. This is how we turn lights on and off, activate appliances, and control the flow of electricity to different parts of our homes. Loads, the devices that consume electrical energy, determine the amount of current flowing through a circuit. A higher load, like a powerful appliance, will draw more current than a smaller load, like a light bulb. The amount of current flowing through a circuit is also affected by the voltage and the resistance of the wires and components. Understanding how electricity flows in a circuit, the role of switches, and the impact of loads is essential for comprehending the dynamics of home wiring. Section 6. Safety first. Protecting yourself and your home. Electricity is a powerful force that demands respect and caution. Always remember that safety should be your top priority when dealing with electrical circuits. Never work on electrical wiring or components with wet hands or while standing on a wet surface, as water is a good conductor of electricity and can lead to a dangerous electrical shock. Before working on any electrical wiring, always disconnect the power supply to the circuit at the breaker box. This ensures that no electricity is flowing through the wires while you are working, preventing the risk of electrical shock. Always use tools with insulated handles to prevent electrical current from passing through your body. If you are unsure about any aspect of electrical work, it's always best to consult a qualified electrician. Attempting electrical repairs without proper knowledge and experience can be dangerous and could lead to injury or damage to your home. Remember, safety is paramount when working with electricity. Taking precautions and seeking professional help when needed are essential steps in ensuring a safe and functional electrical system in your home. Section 7. Conclusion. Mastering the basics of home electrical circuits. We've journeyed through the fundamentals of home electrical circuits, gaining a clearer understanding of how electricity works, the components that make up a circuit, and how these components interact. We've explored the difference between series and parallel circuits, the role of switches and loads, and the importance of safety when dealing with electricity. This knowledge empowers you to approach home wiring with greater confidence and awareness. Whether you're troubleshooting a minor electrical issue or simply seeking a deeper understanding of your home's electrical system, this guide serves as a valuable resource. Remember, even though electrical circuits are based on simple principles, safety should always be your top priority. By applying the knowledge you've gained and prioritizing safety, you can effectively navigate the world of home wiring. Continuously learning and seeking professional help when needed will further enhance your understanding and ensure a safe and functional electrical system in your home. As you continue to explore the world of electricity, remember that every switch you flip, every light you turn on, and every appliance you use is a testament to the fascinating interplay of energy, circuits, and the principles we've uncovered together.